Binary trees are the closest us software engineers are going to get to touching grass, so might as well understand how they work thoroughly. For this problem, we need to find out whether the overall tree is height balanced, and we can do that by applying a recursive function to the tree and using a bottom-up approach. Whatever logic we have, we perform it on the left subtree, then the right subtree, and finally the root node. So let's get started. For each node, there's two things we're trying to find: the height and the balance factor. The balance factor of a tree is the height of the left subtree minus the height of the right. We perform a depth-first search and go to the leftmost node. The height of this tree's children is 0 as they do not exist. Thus, the balance factor of this tree is 0. And since we're using Leetcode conventions for height, the height of this node is 1. We now move to the leftmost node on the right side, and we see that this tree also has a balance factor of 0 and a height of 1. It's the same thing for the right side. These results now propagate upward to the parent node. The height increases by 1, but the balance factor is still 0. And these results propagate to the root node, where we see the height is 3 and the balance factor is 2 minus 1, so 1. Since the root has a balance factor of 1, it is a height-balanced binary tree. Now, let's look at an incorrect example. Once again, we apply recursion and use a depth-first search to go to the leftmost node. The height is 1 and the balance factor is 0. We then move to the right subtree and see that it returns the same thing. These results propagate to the parent. This process continues until we're done with the left subtree and see that it has a height of 3 and a balance factor of 1. We move to the right subtree, get its result, which now propagates to the root node. This time, we see that the root has a height of 4 but a balance factor of 3 minus 1, which is equal to 2. Unfortunately, because this is greater than 1, it is not a height-balanced tree. Moving on to the debrief, we know that the space complexity is constant and the time complexity is O of n as we are traversing through this binary tree. And in regards to the common gotchas, just make sure you have the correct base case and conditionals in place. Here, if the root is null, we return a true value because it is a height-balanced tree. And if the balance factor is greater than 1, we return false. And I think I've taken enough of your time for today, so thank you everyone for watching. And if you enjoyed this, make sure to check out other videos on my channel.